All right, so thank you for coming. My name is Pedro. I can be a fast speaker sometimes, but yesterday I ate a lot of meat, so I think I'll be slow and it will be good for you guys. So a little more about me in case it matters. I'm from Brazil, but I don't speak Spanish, and I'm ashamed to say this. I think it's terrible. I should be here speaking Spanish to you guys, so I'm deeply sorry about this. I did study Spanish for a year, but all I can do is the Portuñol, and then I think I would offend your families or something like that without knowing. So just stick to English and move on. So in Brazil, back in 2005, I was opportunistic enough to register rubyonrails.com.br. And then we translated the docs and some tutorials, and then I guess that's how I started participating in the community in Brazil. I wasn't the first one or the only one for sure. As you guys might know, the community is quite big in Brazil, but I was around at first. And then 4 years ago, I moved to the States and joined Heroku. So how many of you guys know what is a Heroku? All right, okay, a fair amount. That's good. So I won't have to explain. But Heroku is a startup, right? In a startup, you don't quite do just one thing, right? You do a lot of things. So one of the things I work with Blake over there, Blake Mizarani. One of the things we did at Heroku is the Node.js support, right? And that was pretty cool. Then I work a lot on refactoring invoices. And today I'm working on API, so whenever you do, Heroku Create or Heroku Scale, you make an API call to us, and the public API is on, my team owns it. What else? Like pretty much everyone else in here, I love Ruby, maybe too much. So this is on Halloween in the US, my first Halloween, right? I put this, the fox mask on. I even have some blood on it. I think I was a little drunk already by the time I realized I need to poke some holes to see stuff. And then I cut my fingers, but I realized it was appropriate, bloody tall fox, whatever. And then Argentina, I love Argentina. I'm so glad to be here. This is from the first trip I did to Argentina in 2006. I love not only the steak, but the people. I love the people in here. So much bright people and, friends. And yeah, I'm really glad to be here. But okay, so let's talk about the things I think every programmer should know about distributed systems. And the first one is the definition. What is a distributed system, right? So going to Wikipedia, with a few changes I did on the vocabulary, a distributed system consists of multiple autonomous applications that interact with each other to achieve a common goal. So if you have a monolithic application, you have one app, receives the user request or the input from the user, and then you go to the database, you do whatever you need to do, and then you go back to the user and you resolve the problem, right, the use case. In a distributed system, you have one app receiving the input, and then you will talk to other applications, they work together, and then they will solve the problem of the user, right? So with this definition set, who here works or worked on a distributed system before? Nice. I see maybe 10%, okay. Perfect, okay. So with that in mind, knowing what is a distributed system, I'll talk a little about the motivation, like why should we write distributed systems? And here I'll talk a little about granularity of code. So when I first started writing code, I guess the first code I wrote in school was something like this, it's all contained in a single function, in the same scope, right? So of course in Ruby, it's implicit, the def main, you don't need anything like main. But in Java, you could imagine this would be public static void main, and then you write the whole code in there and run that, right? And that's how it starts. So this code, I would say this has low granularity, it's all defined in the same scope. And this is not the code we want to deploy, right, or we want to write. This code is hard to maintain, and it's hard to test. So as we add granularity, as we keep splitting this code into methods, you can see the other extreme, how it would look like, right? So you have a lot of methods, and they have 1 or 2 lines each. And this is this extremely high granularity code. And it's also not good. It kind of sucks too, because if you want to understand this program, it's very hard to read it, right? You have to read a function and then follow all the calls. And I guess our brain is just not good with stack trace and stacks and all of that, right? It's hard to understand this. So ideally, we want, of course, to be somewhere in the middle, right? Somewhere in between. And I feel like good programmers know exactly where they want to be. I work with some really good programmers, and I feel like somehow they just feel that a method is too long. They'll just they won't even think too much. They'll just split it in two and make everything beautiful. And I think that's definitely a quality of some programmers. Now, talking about granularity, so if you're programming with objects, right? So like I said, you have methods to control your granularity, right? So you can have a big method or 10 methods with one line. Now, with OO, you also have classes. So you can have one class doing everything your system has to do, or you can split this work across 10 classes, each one with 1 or 2 methods, right? And of course, you have packages too, so you can throw all your classes in the same package, in the same namespace, or you can have one class per package if you want to, right? And then languages, I think it's funny to think, but languages also bring you new ways to control your granularity. So Ruby, for instance, everyone knows you can change the amount of files you have without changing the amount of classes. And this was what I found really cool about Sinatra when I read the code back in the day. Sinatra has all Sinatra was contained in one file. You just required that file, and then you were ready to write web apps. And I think that was pretty cool. Now they moved away from this model already, but this seems to be an emerging pattern. I don't know if you guys know Uncle Bob. He's a famous programmer. He wrote an article called SRP in Ruby, where he says, he kind of explores this idea, he will add files to define the same class. So he'll change, the granularity of files, but keeping the same class. So he'll, reopen the class and add methods to it. And with this, he believes he can write cleaner code. Now, Java, on the other hand, won't allow you to change the files without changing the class, right? It's almost like it's bind together. So if you want to add a class, you need to add a file. If you want to add a file, you need to add a class. So if you try to implement something like Sinatra did in Java, you wouldn't even be able to compile your code, right? And now PHP, just to give one last example, it didn't have namespaces or modules until recently, right? So you could only change your granularity in terms of classes and methods. So that's for languages. And one last thing that brings new units for you to play with granularity is, of course, the architecture of your system, right? So like we talked, distributed systems, you can have one application doing everything, or you can have 10. So, and this is what really interests me. I think we don't think too much about distributed systems in terms of just writing better code, right? We usually do distributed systems when, for instance, if you want to have 2 languages, if you want to have your application written in 2 languages, you would have 2 apps, and then you figure out a way for they to talk. And that's an obvious case, right? But here I'm saying, even if you're in the same language, you might want to split your application just to make things more clear and better to test and better to understand. So this is for granularity. And now, I guess the next topic of my talk, on distributed system, is the evolution of Óbidos. So Óbidos, if you don't know, well, I didn't, it's a city in Brazil, and it's the city in this peculiar place where the Amazon River, which is one of the biggest rivers in the world, all the different branches of the Amazon River comes together on the area around the city. So you can see, if you are an engineer working at Amazon.com, how this could be a good name for your system. And this is what happened. So Amazon.com, if you went to their website and bought anything, the system that would receive this request was called Óbidos. And it's kind of ironic because Óbidos was a monolithic system. So everything, the product pages, your cart, your billing information, everything would be received by Óbidos. So I think it's a little ironic because maybe a better name would be South America, which is what contains the Amazon River. It's not it's not what emerges. It's what contains the whole Amazon.com, right? But anyways, they did Óbidos, and then of course they started growing, and they eventually retired Óbidos and replaced by a distributed system, right? Now I can't say exactly why they did this because of course I wasn't there. But what I can tell you is that it seems like a bunch of companies, they share a similar trajectory. They do this similar pattern. You start with a monolithic or a single system, and then you start splitting it and growing from there, right? So what I can tell you about is Heroku, of course, as I'm working there for a long time. So think about Heroku. Just for example, I throw in there 4 things we have to do for our users. So, of course, we need to do instance management, right? We need to talk to EC2 to provision new instances. We need to map ELBs to instances and all that stuff. We also need to track your usage so we can bill you, so you can send you invoices. And we need to do this thing we call process orchestration, which is like a state machine of a process running on Heroku, right? So for instance, when you deploy your code, we need to bring your old code down and then bring a new version of your code up and all that stuff. It's a very sensitive part of the architecture, but it's definitely something we have to do well, right? And finally, we need a public API. That's the team I work on. We need an API so you can scale dynos and create apps and all that stuff. So I think you guys could be surprised by this, but this is our own obvious. Like this was all called core. When I joined Heroku, in the first days, we had a big Rails app, and it did all those things. So one of the big tasks, or the first big task I did at Heroku, was to take instance management out. And this probably sounds obvious, right? Like it seems easy to do this cut, and there is a simple reason for this, which is the domain of those apps is very different. So core has users and applications and invoices and billing, and then on the other hand, on the other side, you have like instances and EC2 zones and ELB volumes and all that stuff. There is no relation between them. So if you have different domains, it's just very easy to cut your application, and then it's a very easy benefit to get. Now, what happened next is a guy, it wasn't me, but Ryan Smith, he joined Heroku, and then soon after he joined, he took billing and invoices out of core. And that was amazing. I don't know, if you guys know, but for us, billing is surprisingly hard. Like, we don't charge, we don't sell a product like, $10 and you get this. We do metered usage, right? So, if you use for 1 hour, we'll charge you for that 1 hour only. So it's a lot of work in billing invoices, but it's definitely a very different cut than the one we saw before, because here the domain, there is definitely a lot of overlap in the domain. So to invoice someone, you need to see who's the user, and then you need to see the apps in the users and what usage those apps have, right? So this is a very different cut, but I think this is the one that paid off, this is the one that mostly pays off. Because it's hard, but then what it allowed us to do is to just change the company organization. There's a lot of talking agile about how teams should be autonomous. And Ryan, he's taking care of invoices, but he doesn't have any autonomy if we have to write code in the same code base, right? He can't change the Rails app. He can't change the testing framework. He can't add dependencies easily. So he just didn't have autonomy, right? So he took a fair amount of time. It took some work, but he took invoices out of core. And as a result, now he really owns billing, and he has the freedom to take, try new approaches. Maybe, he is using another language, other testing frameworks, and it was a really good cut for the company. I guess that's my point. What happened later is kind of similar case. Mark Fine, another engineer of us, he took process orchestration out of core. This is kind of, it's kind of a mix of both cases. For one side, it's kind of a different domain, right? The state machine of a process doesn't need to live together with the app, but there is definitely some overlap. You need to know how many dynos or how many workers an app has so you can run it, right? But Mark Fine, he wasn't working with me in core. He was on another team, the runtime team, the team that is in charge of running processes on Heroku. And then he just took this out of core so he could keep it for similar reason that Ryan took invoices out so he can own it. And now what we have in core these days is mostly the public API with a few other things we quite want to take it out. So I'll definitely be very happy that they can rename core to API and know that core, all that core knows or all that core has is the Heroku API. So really good for the company. I think this is being able to cut a system like this just to allow a different company organization was very valuable for us, and it's definitely part of our history. So I hope you guys, so now I understand what is a distributed system. There's a good motivation to do that from a code side, so your code looks better. From a company side, so you can change the structure of your company around your system. So now let's, how do we get the hands dirty and write a distributed system, right? So basically, I think the first problem and the major problem is how do you write the bridge between two components, right? We talked before about methods. With methods or classes, like this comes for free. You can rewrite that big, 100-line methods in a bunch of small methods, and then the Ruby interpreter will just link things for you and it will just work, right? But with a distributed system, you are in charge of the medium. Like you have to put those things together. So you have to write code, you have to keep a new component, and you have to make sure it's always running, right? So I guess the first solution to this problem is sharing the database, right? That's, I think it's the most convenient. It's the first thing that comes to mind. So the idea here is that, one app will throw something in the database and then another app can use it. So if you think about Heroku, one app could be core writing users to the database, and the other app could be getting the users out and then writing invoices right on the same database. So it's easy to do, it's convenient, but I would tell you don't do this. And I think the biggest reason here is that this is just failing to realize there is a contract between those two components. So it's almost like throwing that under the carpet. It's very easy to do this and not establish a contract. So if you think your database is the contract, then how do you test it? How do you version it? The database is just not written for this, right? So there are better things to do here. So blow away that idea. And REST is, of course, the second most popular approach. And the way it works, in case you missed the last 5 years of Ruby, you have an HTTP, client here. It could be a REST client, the one, someone Heroku wrote and we like, but it could be HTTP party or whatever you like. You get a URL, some server on the other side, written in Sinatra or Rails or whatever you want, will get the request, do something, and then respond back, right? So it's well known, it's accessible, it's good to test, it's convenient. But I guess there's only two things we didn't quite like about REST. So I'll just share with you, so maybe you can keep that in mind if you're going to use that architecture. One is, if this request takes a long time, you need to watch out. Because you don't want your server blocked so it can respond to more requests. And you probably don't want your client blocked too while it's waiting, right? So there are definitely things you can do about this. For instance, you can write your server using evented programming, right? Something like Event Machine or Node. Or maybe you can put a worker in there so you offload the job to another process and then you go back. And whatever you do, you kind of have to architecture your API in a way that makes sense. Because now the API is not like request something, get it back. The API is like start working on something, and then either I'll pull you to see when it's done, or you're going to tell me when it's done, right? So it's a little tricky. Another thing we didn't like too much about REST is that it just lacks flexibility and performance. So especially if you have one system talking to multiple others, things start to get slow and doesn't look too good in REST. I think REST is a peer-to-peer communication. So if you start adding more components to the mix, it starts getting ugly. So the next approach, and the final one I'll cover here, there are many others, right? But I'll just give you a brief picture of what are your options, is of course MQ, which stands for messaging and queuing. So the idea is that you bring a new component to the mix. You bring this new thing to your distributed system, which is a broker. And then he'll receive messages from someone and deliver those to one more system or maybe many others, right? So it's definitely very powerful. There's a bunch of options in the broker, like some really cool stuff like TTL on messages or broadcasting, and a bunch of advanced features. And at Heroku, we've been using, there are several implementations of MQ that you have available. At Heroku, we've been using AMQP, which is probably, it's a popular one. It's serving as well. And the idea, just so you have some clear idea of how it works, is basically you have, on the receiver side, you initiate AMQP, and then you get a queue, which is, a queue is where you exchange messages, and then you throw a message on that queue. You don't even know who's receiving, or if someone is receiving. All you care is that the message gets sent, right? And then from the other side, from the receiving side, you subscribe to that queue, and then whenever you get a new message, Event Machine running behind AMQP will yield the block to you so you can do whatever you want. You can, send a message to the user or add a SSH key or, whatever you want. So it's we really like MQ. We've been using it for quite a while. But as usual, it's not perfect. I guess there's no perfect solution for the medium, but we do have two pieces of advice, I guess. One is that you should get ready to spend a lot of time researching. It's a different protocol, so I guess we all know HTTP fairly well, but when you add a new protocol to the mix, you should, it takes some time until you feel confident about using that on production. I guess it's my point. And the second one is that there is a mismatch between MQ and REST, right? So if your application is receiving REST call, HTTP calls from your clients, and if you're using REST inside your application, then it's convenient. It's all the same protocol, and you know it fairly well. But if you're receiving REST and then using MQ for that point on, you kind of have this weird barrier where you kind of have to translate between protocols, and that can get weird. So yeah. So those are, I guess, two fair warnings about MQ. And then finally, I'll bring some challenges, I guess, about what other things we found out while doing distributed systems on Heroku. So the first one is, of course, the medium, and then after you get that figured out, you run into a few things. You probably run into those things, not necessarily in this order, but in some order. And of course, any of those topics are probably worth a talk of itself, but I don't have time, and I don't know that much, so I just tell you like how is it working for us, and then hopefully give you some directions of where to go when you find issues on those areas. So first one, of course, is versioning. So if you have a single application, versioning, it's a well-known problem. You just tag your releases, and then you can roll back easily, and all of that. But now, if your system is composed of multiple applications, you have to decide how to do versioning. So how we started doing at Heroku is basically doing a tag on all components we deployed. So whenever we deployed, we create a tag across all the different components. Like you are all now on V104. And then that's how we deploy. So rolling back means basically rolling all the components back to a different version. That worked well for us for some time, but it's not too clean, right? If a component is getting updated constantly and another one is not, you get a bunch of tags that have no change on them. So what we did is that now we have basically a release manifest, which is basically a tag mapping a component to a version. So each team owns their own versioning, but we all as a whole can roll back and do all that stuff. Next one is testing, and it's probably the biggest challenge, I think, on this area. The problem is that you can easily get into a situation where both systems have green specs and everything is passing, but when you throw that on staging or production, nothing works. So that is really a lot to talk here, but I think you really have to understand the value of integration testing to avoid issues here. And just establishing contracts, right? Like whenever I depend on another team, like there should be an API that has a version and like it's like specified and tested, and they won't just change that because they added, like they shouldn't break APIs. Another thing about testing, Angie Del Cambre gave a really good talk about this on RubyConf. So if you guys are interested in testing multiple systems together, I would encourage you to check that out. It's online. Next one is authentication. Especially if you spread the notion of a logged-in user, you might end up in a situation where a system get a call and it needs to know, oh, who is this user? Or can he do this thing? So it turns out that SSO, which is single sign-on, is surprisingly hard. There are like several ways to do it, but we're not quite happy with any of them, I guess. So what we're doing is a very simple solution where we send a user with a token to another app. If you would like to see this, you can probably just refer to the add-ons documentation we have at Heroku, because this is what we do actually in production. Like when you go to Heroku and you log into New Relic, we establish an SSO, with New Relic, so you can see how we did that on the docs for add-ons. And of course, you can always take a look at OpenID and all those more standard solutions for sure. Next one is the development environment. So you want new members of your team to be able to get their the environment's bootstrapped. And you don't want the time they take to get this grow as you grow your systems, right? So you want to keep that down. So what do we do at Heroku? I guess a big part of it is having good docs. So all of our code, you have a good doc, and more than that, a standard way of getting the bootstrap done. So all the code is on GitHub, and all components, like all the Ruby components, have a Gen file, have a README, a rake test, a rake test to test, and yeah. So you should definitely use the standards here to avoid making the bootstrap too hard. Visual consistency is also a big one for us because we have different apps serving different parts of our pages. So for instance, if you go to addons.heroku, you see the Heroku nav, and you see, if you're logged in, you see a logout button and all of that. But that's another app. It doesn't actually know which Heroku user are you. So if you split your system in a way that multiple apps has to serve the same interface, you probably bang your head against the wall and ask yourself, why can't I use iframe? Which is what we do every day. But iframe doesn't provide a good UX. So what we had to do in the end is basically we have an API where our different components can fetch the Heroku header and CSS, and then they use that. And together with that API, we have a gem that knows how to fetch the header and cache it and all that stuff. So it's pretty easy today to write a new Heroku app with the same uniform visual details. But yeah, it took some work. And finally, deploying, I guess it's not a challenge that comes with distributed systems, but for sure it gets harder with distributed systems, right? So deploying one system, you deploy, you run migrations, you can roll back, you know how it is. But now, if you're deploying multiple systems at once, you need to, adapt your deploy process to handle that for sure. So what we do is, of course, we self-host whenever we can. So, if you go to Heroku.com, that's a Heroku app running and serving, our public pages. If you go to items.heroku.com, that's another Heroku app running. But of course, the kernel we can't self-host, or at least not yet. So for the things we can't self-host, we have a deploy. It's like a deploy script that knows how to deploy, using the versioning I talked to you guys, and helps us deploying, the whole cloud at once. So I guess to summarize, one, it's important to know what is a distributed system. Like, it's nothing crazy. It's nothing only universities do. Like, it's something that will make your code look better, hopefully, and it's something that will allow your company to grow and to form teams around the things that matter to the company instead of just what happens to be the state of the code. Then develop the medium, put a lot of effort into it, know how your components are talking to each other, and then get ready for the other challenges that you might face. So thank you. This is my email if you have any questions, or I'll be around for sure, so you can stop me anytime. I love talking about this stuff. I'll put the slides on my blog. I update it like every 2 months or something, so I guess it's time. And my Twitter is PAD. Thank you. So I do have 4 minutes, I believe. All right, so any questions for now?
Sí, yo soy como dije en otras preguntas, un novato de Ruby. No escuché en tu charla escalabilidad. No sé si se enfrentaron con eso, cómo lo solucionaron, si MessageQ está involucrado con eso. Por ejemplo, vi ahí que en el AMPQ pones directamente el host y no sé si no podés hacer un host transparent, algo que lo tome cualquiera y puedas poner más máquinas y escalabilidad para afuera. No sé si entiende la pregunta.
I think so, yeah. Yeah. So in scalability, that's a great question. I didn't touch this. I think people, like I said, when you want 2 different languages, you do a distributed system it's kind of obvious. And scalability is another one that I feel maybe it's not as obvious, but it's just a natural choice you have to take. So if you have a big system and you start to find bottlenecks inside it, then you probably will ask yourself, like, should I split this, take this out so I can scale this horizontally, right? So definitely scalability is definitely something you can explore with distributed systems, and in particular if you pick the right medium, right? So if you're doing a database, your database will be the bottleneck, like next thing, right? Everything is going there. As soon as the database is slow, your whole system is slow. Whereas if you pick something like AMQP, you definitely have more options to scale. It doesn't come for free, but you will have the right tools to scale your messaging bus efficiently.
He said that you have to put the address of the host where you're connecting to.
Oh, right. Oh, right. So you can have I'm not sure about AMQP, but you can definitely load balance that out. Especially, I guess, RabbitMQ in the latest version, they have, it's not segmentation. But yeah, they definitely have more options for this. And other queuing, so like I said, there's a bunch of queuing options. So 0MQ might approach this problem in another way. But yeah, usually the idea is that you can connect to like a load balancer that will distribute your messages.
Hello. Hi. Pedro?
Oh, hey.
Hey, if you could suggest how to implement single sign-on using Heroku, what you think the best practice would be? Should we follow your model, or maybe go with OAuth 2 or something like that?
Right. So you mean single sign-on between your applications, right?
Yeah. Also sharing user database, perhaps, as between those 2 applications.
Right. So the way we do, it's very easy. Basically, you send a user to another app, and you pass a token, like you pass a hash, and you share the strategy to create this hash among the 2 apps. So you can definitely pass more information on that session. So for instance, you can pass the username and the email and the company it works for, and then on the other app, you have that information for the session, right? The problem with this is that if the user goes back and changes the information, you won't get the new stuff on the other app, right? So if you have a sensitive requirement, like you always need the latest information, the solution we have is probably, at least right now, is probably not the best one. And then I would definitely recommend OpenID and OAuth. I just personally, I try to avoid it because it's pretty complicated, right? I don't know if you guys ever wrote code using OpenID, but it's so hard to understand and it's so hard to test, right? So yeah.
Yeah, it's really tough.
One more question?
Yeah?
Chat?
Yeah, Pedro, you guys use a lot
Chat.
Everyone's going to laugh that I asked this, but how much Erlang are you guys using? And when are you going to support Erlang on Heroku?
Ooh, okay, so we use Erlang. So there is a team, there's the routing team, and it takes care of routing not only of HTTP requests, but also we think of routing in terms of like routing streams of information, right? So they also do the logging service on Heroku. So whenever your application logs, it uses syslog and logs to a router that will, route the syslog message. So we have those two components written in Erlang. And as far as support, I'm not sure right now. I'll have to get back on this.
Well, thank you, Pedro.
Thank you.